Hi everyone! Salamat sa inyong patuloy na pagsubaybay dito sa ating channel. Our discussion for today shall be about mechanics of deformable bodies. And we shall have series of discussions about this subject. At magsisimula tayo sa pamamagitan ng discussions ng overview of the mechanics of deformable bodies. At sa pamamagitan ng simpleng discussions nito, ay makikilala natin sa kabuuan ang subject na mechanics of deformable bodies. In the later part of this discussion shall be a presentation of sample problem that will explain the different concepts about the simple stresses and that of the normal stress, the tangential stress, and the compressive stress. At simulan natin ang discussion with a simple object that is subjected to an external forces like F sub 1, F sub 2, F sub 3, and F sub 4. And let us imagine that this object is in equilibrium. When this is in equilibrium, if we will pass an exploratory section that is perpendicular to this longitudinal axis, at sabihin natin this section will cut the object into two parts. Imagine natin that we have passed here an exploratory section. Diba? If we will consider the left part of the exploratory section as free body diagram, consider natin itong left part as free body diagram, then we shall have this as our isolated view of the free body diagram. And let us imagine further that the exploratory section be defined by the two mutually perpendicular axes, and we will be calling them as the y and the z axis. So let us have this axis. This shall be our y-axis, and this shall be our z-axis. Since the whole structure is which is subjected to the different external forces is in equilibrium, then itong left part daw nito, at kahit aling part pa na in-isolate natin as free body diagram, must also satisfy the conditions of equilibrium. Kaya, for that condition to happen, then the exploratory section, itong section na ito daw, must be subjected to an internal force which will balance the effect of all those forces acting on the left part of exploratory section. Kaya inaasahan natin dahil nga pinutol natin siya, we take the left part of that exploratory section, merong natirang dalawang external forces na nag-act dito, then of course because of this cut section, masasubject siya sa unbalanced forces. And for this to remain in equilibrium as this should be, this should maintain an equilibrium, then this section which is cut by an exploratory section must be subjected to an internal force that will keep the left part to be an equilibrium. And imagine natin that that force is represented by this force P acting somewhere here, directed in this direction. According to the discussion, this internal force P will cause an internal stress upon the body. Ito na yung magkakos ng internal stress upon the body. At ito ang magiging kabuuan ng tinatawag nating mechanics of deformable bodies. The type and magnitude of the stress that will be caused by this internal force on the exploratory section shall be dependent on the position, the direction, and the magnitude of that internal force. Kaya yung daw na stresses na madidevelop dito will be dependent kung nasaan ito, anong kanyang direction, at ano yung kanyang magnitude. At sa kabuuan, diyan iikot yung tinatawag nating mechanics of deformable bodies. Para maunawaan natin yung epekto, subukan natin na i-resolve itong P into components along the X, along the y and along the z axis. At tawagin natin siyang px, py, and pz. So, i-resolve natin siya into components so that we shall have our px, our py, and our pz. These are the component of the internal force that is acting upon the object. Okay? That balances the exploratory part, that balances the left part of the exploratory section of the body. Now, if the components of this P shall be moved to the center, no, of or the intersection of the x, y, z, then it will be producing moments about the x, about the y, and about the z. As we have learned in our statics of rigid bodies, if a force is moved from one position to another, it will be producing a moment. Kaya kapag ito daw ay gagalawin natin, papunta dito sa gitna nito, diba? May mapoproduce tayong moment about the x, about the y, and about the z axis. Kaya ganito yung mangyayari, tingnan nyo mabuti. Ano? Kapag i-move natin siya dito, so may napoproduce na x, na moment about x, moment about y, and the moment about z. At sa kabuuan, kapag pinag-aralan natin yung magiging epekto ng lahat ng ito, itong px, py, pz, moment about x, moment about y, ito, at yung moment about z, shall be the entirety, yung kabuuan ng tinatawag nating mechanics of deformable bodies. Sabi nga, the type of stresses to which the body will be subjected are the following. Una, meron tayong tinatawag na normal stresses. Ano? Meron tayong tinatawag na normal stresses. At siya nga yung tinatawag nating normal dahil sa relation ng force na magkakos ng stress doon sa area na nagre-resist ng force. This is the stress caused by the component of P along the x-axis or normal to the resisting area or exploratory section that is used in the analysis. Kaya kung makikita natin ito yung tinatawag nating okay, P. Ito yung P. If this P is normal or perpendicular to this area, then the stress that will be caused by this P shall be called as the normal stress. And that normal stress could be either a tensile or tensile stress, okay, which is represented by sigma sub T. And this is caused by P sub x if P sub x is directed away from the exploratory section. Ang madedevelop daw na stress that will be caused by the P sub x shall be in the form of a tensile stress kapag daw itong P sub x is directed away from the section. And its effect is to cause an elongation in the material along the direction of the longitudinal axis. Ang epekto niya is to cause an elongation in the material. And the direction is directed along the direction of the x-axis where the P is also directed. The second type of normal stress is called as the compressive stress, and this is given by the symbol sigma sub C. The C is used to differentiate it from T, as this is caused by a compressive load. So what is this compressive stress? It is the stress caused by P sub x, the same force, the same force. Okay, when P sub x is directed towards the exploratory section. Kapag daw ito ay directed towards the exploratory section, gaya ng ipinakita dito. Yan, pakita natin dito, Yun yung tinatawag ng stress that will cause, the load that will cause the compressive stress. And the effect of this compressive stress is to shorten the material along the direction of the longitudinal axis. Kabaliktaran ng epekto ng tinatawag nating tensile stress. There will be a shortening effect. Okay, a compressive stress will have a shortening effect on the material, and the direction of which is directed along the direction of the x-axis or the direction where the force is directed. The magnitude of stress is computed using the relation between the tensile load or the compressive load divided by the resisting area. Kaya kung meron tayong compressive stress, it is equal to P sub C over A, na kung saan yung P sub T at P sub T are the component or are actually the forces that are directed normal to the resisting area. An area is the area that resists that load. Kumbaga, ito yung ating nakikitang area. Yun. Itong nagbabago ng kulay nito. Ano? So, yun yung ating area. So, what will be the unit? The unit will be whatever is the unit of the load divided by the unit of the area. The second type of stress is known as the shear stress. Okay, shear stress is caused by the component of P that is parallel to the resisting area. Ito naman daw yung component of P that is parallel to the resisting area. Ipinakita ko na kanina yon, so ibalik natin yung force na yon. Kung itong P na ito is acting parallel to the resisting area which is directed along the z-axis, then this will be causing a shearing stress. Okay, we also have this P sub y. P sub y, which is directed either upward or downward depending on what is the direction of the resulting force acting on the exploratory section. And what is the effect of this shear stress? The effect of shear stress is to cause sliding of one section against the other. Ang naging epekto nito is to cause sliding, lalo kapag nag-fail siya, ang ibig sabihin niya, it will cause sliding of one section upon the other. So, ipakita ko yung epekto niyan. Ibalik ko lang ito para makita natin yung maging epekto niyan. Ganito ang nagiging failure. Kumbaga, ang naging epekto ng sa body kapag ang body na subject sa shear stress at yung shear stress ay sobrang laki that it cause failure of the structure. So, it will be causing the sliding motion or sliding of one part of the body against the other part. And this is what will happen. So, yun. Because of the P that is acting parallel to the area, okay, the left part is pushed downward, okay, by that component. So there was a sliding of this segment against the other one. So balikan lang natin, ganyan nakita natin, ano? O kaya naman, kung P sub C naman ang tinutukoy natin, ito yung nakita natin, ito, ang tendency niyan is to move in that direction. So it will be moving, causing the sliding of the part in that direction. Okay? So, the magnitude of shear stress is computed as the ratio of the shear load. Yun yung shear load na tinutukoy natin dito, yun yung component of the P parallel to the resisting area. Yun yung PX at saka yung PY na ipinakita natin kanina. No? While the area is the resisting area, this area that is cut by the exploratory section, such that our shearing stress given by the formula tau, which is equal to V over A, na kung saan yung V, yun yung tinatawag nating shear load. In our explanation example kanina, yun yung ating P sub Y at yung ating P sub Z, because these are the loads that are directed parallel to the resisting area. Okay? The other type of stress that we shall have, are the torsional stress. Kumbaga, ito yung further, yung torsional stress, or simply they are called torsion. Ano itong torsion na ito? These are the stress caused by the twisting of the body due to the moment about the x-axis. Di ba pinakita natin kanina, when the force that is acting here is moved towards the center, kaya nagkaroon na puproduce yung tinatawag natin moments about x, about y, and about the z-axis. Yung moment na na-produce along this direction or along the longitudinal axis will be causing a twisting effect on the object na pipilipit ngayon, yung object, di ba? And the stress that will be caused by this moment shall be called as the torsional stress, or simply called torsion. Itong part na ito will be discussed later, in the topic. Kung usual ka, kung familiar ka with the strength of materials ni Ferdinand Singer, itong topic na ito is discussed in chapter 3. Nasa part siya ng chapter 3. The other stresses are the flexure or bending stress, and these are the stress caused by the bending of the material due to the moment about the y or the z-axis of the exploratory section. So, mapasin natin, kung ito yung ating z-axis at ito yung ating y-axis, merong na-produce na moment, di ba, nang mag-move tayo from here to that point along the y and along the z-axis. Itong dalawang moment na ito will be causing what we call a bending effect of the material. And the stress that will be caused by that bending effect is called as the flexure or bending stress. And in most books, okay, it is found on the later part after the torsional. Kaya sa kabuuan, diyan iikot yung ating discussion dun sa analysis of internal stress. Iba't ibang section nga lamang o iba't ibang object or body nga lamang ang ating ma-encounter. But nevertheless, doon yun yung magiging kabuuan ng ating discussions about the mechanics of deformable bodies. Tingnan natin itong isang example na inihanda ko para maipakilala natin kung paano ba ina-analyze ang body and how do we define and how do we determine the stresses. At simulan natin sa pamamagitan ng pag-analyze ng tinatawag nating tensile at shearing stress. And here is the problem. The inclined member in the figure is subjected to a compressive force of 12 kN. Determine the average shearing and tensile stress developed in the lower horizontal member. So, meron tayo dito actually na isang element which is actually a part of a truss. Ito yung tinatawag nating top chord, and here is the bottom chord of a truss. The top chord is subjected to a 12 kN load and is inclined at an inclination of 4 vertical and 3 horizontal. It is supported by a bottom chord and whose dimensions are indicated. The width of the bottom chord here is 40 and the dimensions are shown as follows. So, paano natin to sosolvin? Let us try to imagine that we isolate the lower part of the structure or the horizontal part of the member as free body diagram. Pakita natin siya and let us have this reorientation. Medyo pinihit ko lang siya para maipakita natin kung saan mag-a-act ngayon yung mga forces. The force, the 12 kN force is acting somewhere here and inclined at an inclination of 4:5. 4:3. The magnitude of which is 12 kN. If this 12 kN is resolved into component, therefore, meron tayo tinatawag na vertical at horizontal components which can be taken by the ratio. Okay, by applying the ratio proportion of this triangle. So that itong ating vertical component will have a magnitude of 9.6 kN while this horizontal component will have a magnitude of 7.2 kN. At itong 7.2 na ito will be actually acting over there, okay, on the element. Diba? So, para ipakita natin dito, yung tinatawag nating tensile stress. Imagine natin that we pass an exploratory section, okay, that will cut the lower element. Okay, itong lower part ng member somewhere here. Kinat natin siya dito, dinaan natin dyan, kinat natin siya dito. And then we isolated the left part of the exploratory section. Kapag in-isolate natin yung left part of exploratory section, na itong pinutol natin ito, will now be subjected to an internal force that will balance the effect of this 7.2. Sa makatwid, if we will be applying the condition of equilibrium that is summing up forces horizontal, okay, will give us the value of the P sub T or T simply T, which is equal to 7.2 kN. And that, okay, if we're going to solve for the tensile stress, this will now be causing a tensile stress. Alin ba yung stress na, okay, alin ba yung area na masasubject sa tensile stress? Yun yung area na kung saan dinaanan natin ng exploratory section, and this is this element in this area. Itong area ito. Having a dimension equal to this 40 multiplied by the thickness of this lower part. Ito yun, 25 na ito. Ito yung 25 na itong bahagi. Di ba? Kaya, okay, if we're going to solve for this stress, we'll have P sub T over area na kung saan yung P sub T is 7,200 Newton because 7.2 kilonewton is equivalent to 7,200 divided by the area of 25 by 40 millimeter gives us a stress equal to 7.2 Newton per square millimeter. And this is also equal to 7.2 megapascal. Ngayon, samantalang ito namang shearing stress na madidevelop ay makikita natin sa pamamagitan nito, no? So, alin ba dyan yung masasubject sa shearing stress? Tingnan natin, balikan natin yung binanggit kanina, no? Yung sinasabi ng shearing stress, it is caused by a load that is acting parallel to the area. Kaya kung pag-aaral natin itong horizontal force na ito, if it is acting over here, it will cause the upper part, okay, of the segment BD to be pushed to the left. And if it is pushed to the left, okay, there will be an area that would resist this part. Para maipakita natin siya, tingnan natin kunwari, nagkaroon ng failure. So that we allow the upper part to be pushed to the left. Pag ipinakita natin, ito yung mangyayari kung masisira siya. Sa mga katuwid, itong part na ito yung tinatawag nating shear load. While this one will be our resisting area. So if we will be dividing this shear load by the resisting area, then we shall be getting the shear stress. And how do we solve for that? So we will be solving for the shear stress. Shear stress has the formula V over A, and the area is the blue shaded area, and whose dimension will be the distance between BD, and that is equal to 75, and the length of this, which is equal to 40, kaya that is 75 divided by 40, and that becomes equal to 2.4 megapascal. Sana ay nasundan niyo yung simpleng discussion or pagpapakilala kung ano ba itong tinatawag nating normal stresses at how are they computed. Once again, thank you very much for watching.